Okay, 1.6 part 2, solving absolute value equations. Now be careful, this is equations and not inequalities. So I'm going to have to um, think back to our geometry days here. Okay, if I start at um, this point 0 and say I want to go um, 4 units, say this is my house, and the school is 4 units from my house. Maybe so. Maybe this is my house, and this is the school. Okay? So if I travel, say I go east and hit the school, go by 4 units and hit the school, it's +4, correct? I went 4 units to the east. Now say, well, before when I get back home and I want, or even before school, I want to go get coffee. Maybe here's a coffee shop. Okay, it's 4 units to the west. Okay, or on a number line, it'd be to the location point -4. So these are like location points. -4 and +4, and 0 would be a location point. Doesn't mean that I I actually go -4 units to the coffee shop. I actually go 4 units, a +4. Now, remember back in geometry, this is a big concept for when you do distance. And we don't go a negative distance. And then I always have a student tell me, well, Mr. T, what if I walk backwards from the house to the coffee shop? Wouldn't that be a -4 distance? I'm like, no, you just went a +4 units walking backwards. Okay. In order for us in mathematics to measure this distance both ways, okay, I have to force this -4 location point to become a +4. And to do that, we use those absolute value symbols or bars. Okay. The definition of absolute value is the distance from 0. In other words, the distance from -4 to 0 is 4 units. Okay. The distance to +4 is 4 units. So we have to put those absolute value bars there. So if we were to take those absolute value bars off, say I have the absolute value of x equal 5, I don't know if you're talking about the location point 5 or -5. So we have to consider both of situations here when we run into an absolute value equation. We're also going to have to do that when we hit inequalities in part 2. Okay, so the way we do this is that what's inside here, remember, just like in here, -4 is 4 units, 4 is 4 units. So we're going to do whatever's inside here, could be +9, or whatever's inside here can be -9. So we end up with, guess what? 2 equations to solve when we have absolute value symbols. Okay, so solve it just like a regular equation. Now this is equal, so we don't have to worry about flipping inequality signs here. So I'm going to add 5, add 5. I get 2x equals 9 plus 5, 14. Divide by 2. So x is going to equal, in this case, +7. Now, it might equal that over here. I'm not sure yet. Let's go ahead and solve this. +5 plus 5. I get 2x equals -9 plus 5, -4. Divide by 2. This time I get x equals negative 2. So got two different answers. Okay. Now let's do some more. I have the absolute value of x plus 3 equals 5. So I'm going to take what's inside the absolute values, x plus 3 equals 5, or take what's inside, x plus 3 equals negative. I have to consider the negative 5. And then I just solve these separately. I get it minus 3 minus 3. So x equals 5 minus 3 is 2. Or, now you could just put a comma there. In equations, you don't need the word or. You could just put a comma there because x is going to equal something over there. Subtract 3, subtract 3, or x equals negative 8. Again, you can write it as a couple different ways you can write this. X equal 2, x equal 8. You can even do it shorter than that. X equal 2 comma 8. Either way, got three different ways you can write the solutions to equations. Okay, now you can even put the negative first. You're going to find myself, I prefer putting the negative first. It's just a habit. Solve each one of these separate. Subtract 3, subtract 3. I get 7t equals negative 7. Divide by 7. Excuse me. T equal negative 1. I'm just going to put a comma here. Subtract 3, subtract 3. I get 7t equal 1. Divide by 7. Divide by 7. And it's fine to get a fraction. 1/7. Okay, of course, they can always get a little more complicated where you have to isolate the absolute value bars first. Okay, it's being multiplied by 2/3. So I'm going to multiply both sides. The easiest way to get rid of a fractional coefficient, multiply it by the reciprocal. Don't forget to multiply this side by the reciprocal. So I get the absolute value of 1 plus 2x equals 3. 2 times 3/2 is 3. Now I separate what's inside. 1 plus 2x, because this is isolated. The absolute value bars are isolated. Now take the opposite of 3, or what's there, positive 3, and solve each one of those. Minus 1, minus 1. I get 2x equals negative 4. Divide by 2. Divide by 2. I get x equals negative 2. Solve the other side. Minus 1, minus 1. 2x equal 2, divide by 2. So here I get x equal 1. Number 4, again, we got some stars there, so I'm going to assume something is different here. First of all, we have to isolate absolute value bars by its term by itself. That might even be the stars, I don't know. So I'm going to subtract 5 from each side first. So I have the absolute value of 2 minus 4x equals 3 minus 5 is negative 2. Now, let's just think about that for a sec. The definition of absolute value is it's a distance from 0. Okay? Whatever's inside the absolute value has to be positive. Can this ever be true that we have a distance equal to a negative number? No, this is no solution. Now, you say, well, what if I didn't notice that? What if I just went ahead and solved this? Well, I'm kind of curious myself. Let's see what happens. 2 minus 4x equals, now we have to take the opposite of what's there. So negative 2 is positive 2. Or 2 minus 4x equals negative 2. Let's solve these separately. Let's see. Minus 2, negative 4x equals 0. So here, I'm going to have to divide by negative 4. So here I get x equals 0. And let's do the same on this side. Minus 2, I get negative 4x equals negative 4. Divide by negative 4. And I get x equal 1. So if I look at this and say, hey, I didn't recognize that, it came out that there's no solution here because this is impossible. I just went ahead and solved it, and I got what looks like to be a normal answer, right? Well, let's go ahead and plug that in. Say, for instance, x equals 0. So if I go back to the original problem here, I have the absolute value of 2 minus 4 times 0 plus 5 equal 3. I don't know, this might work, I don't know. So I have 2 minus 4 times 0 is 0. The absolute value of 2 is 2 plus 5 equal 3. Well, that obviously doesn't work. Okay, so this is an extraneous solution here. This can't work, not working. And I'm assuming that's what's going to happen with the 1. Okay, so try to step back. When you get the absolute value bars isolated, step back and see if it makes sense. All right, number 5, real quick. I'm going to add 3. Well, I have to see how I have to get these absolute value bars by themselves. A couple operations I have to do here. So I'm going to add 3 to both sides first. I get 5 times the absolute value of 2 minus x equal 15. I still have to divide by 5. I get the absolute value bar 2 minus x equal 3. Now I can separate them. 2 minus x equal negative 3, or 2 minus x equal positive 3. Solve each for x. It's a long problem. Minus 2, I get negative x equals negative 5. And just multiply by negative 1, I get x equal 5. Or minus, bring this up, minus 2, I get negative x equal 1. So on this side, I get x equals negative 1. And that's my answer. And that's it for 1.6 part 1.